Wow, we've made it to part 3. In this section, we may do some academic soul searching, but definitely we will explore some basic strategies to help us build academic concepts in all of our learners. Be sure to download some of the resources provided on the web page for this lesson. Let's begin. We would like to share an important perspective from the National Center for Urban School Transformation. This consortium has been involved in nationwide research for the purpose of improving urban schools, but do not make the assumption that this research is unimportant to schools in rural and suburban areas. Researchers at NCUST found that the teachers with the strongest outcomes consistently pre-identify academic vocabulary that influences understanding of the lesson content. They teach the vocabulary of the concept, they organize how they will build a new concept for learners, and they give students opportunities to practice the words. Teachers with the strongest outcomes in learner academic achievement are very deliberate in the way they build concept, especially for English language learners. Now, we just said that strong teachers give students multiple opportunities to practice the vocabulary and the concept idea in their own words and in their own language. But they also consistently help these English language learners to use the vocabulary in English with small group activities. The key point is they teach the words that build the concepts. What we have here is a concept map. As you can see from Ausubel's theory of concept assimilation or acquisition, wiring new concepts into neural networks is a highly complex process. In our last segment, we looked at 3 basic theories: prototype, rule or definition theory, and exemplar theory. Can you see how these 3 simple theories are integrated into this complex framework? On a different note, if you fail to plan, you plan to fail. Stephen Covey said that in his 7 Habits of Highly Effective People book. If we don't deliberately plan when teaching a new concept, chances are there are going to be learners in our classroom that will fail to learn it. As you can see from this concept map, there are highly complex steps involved in teaching a concept and learning a new idea. No matter what subject area, we routinely must teach basic concepts to build more advanced learning. Use the concept you identified in part 1 of this lesson. If you identified a process instead of a concept, identify another concept right now that you have taught so many times you probably do not even need your notes. You could teach it in your sleep. But is that what you are actually doing? You've got your groove on where this concept is concerned, but ask yourself this question: have I perfected teaching this concept so well that all my learners get it every time I teach it? If that is truly the case, you probably don't need the material that follows. But if you think that your thought processes about teaching concepts might need some reflection and refinement, keep on going. Step 1 in any concept formation is to analyze the concept before teaching it. Identify an important concept or key idea in a content area lesson. Consider the characteristics of the concept. Have you got your concept identified? Good. Let's blow it apart and see what happens when you reconstruct it. Step 2 is to consider the cognitive demand of the concept. If you are teaching learners with limited English proficiency, the cognitive demand load may be heavier than you think. The best place to start is with the senses. Is the concept related to something concrete? Can they touch it? Can they feel it? Can they hear it or taste it or smell it? Can they experience this concept through one or more of the 5 senses? If that's the case, your work is almost done. However, if the concept is a little more abstract, there's more work that we must do. For an example, think of the concept of sour. If you could not taste sour, how would you describe it? When the concept is more complex, more abstract, we must be even more careful in building it so that our students can comprehend it and transfer to future learning. I'd like you to look at the concept that you brought to this lesson, or the one you just identified. We're going to look at step 3, the nature of the critical attributes. First of all, is this new concept narrowly defined? Check things off that apply here. Is it defined through a few converging features or characteristics, opposed to divergent or multiple features or characteristics? What critical attributes distinguish this concept from other related concepts? What rules or criteria define the concept? What qualities or characteristics or attributes are essential in classifying this concept into its class or category? Obviously, we are talking about rule theory or defining features theory. This can be a very existential process. You might find out more about your target concept, the one you chose, than you ever wanted to know. Stop the video for a few minutes if you like so that you can see this slide. Look at your target concept through the lens of this slide. What can you say about this concept that you did not really consider before? Is this only a philosophical exercise? No. This thought process touches on all that we know about how children learn and form conceptual structures. Continuing with the nature of critical attributes, is your concept more broadly defined? Does your concept represent a system? How are the component parts related to each other? How do they act on each other and respond to each other's actions? Are there clear examples and non-examples that illustrate and distinguish the concept, rule, or criteria? We're talking about exemplars here. We might best view this aspect of critical attributes with a good old concept map. Look at your target concept. Does it fit any of this set of attributes? While we fall back to exemplar theory here, notice how integrated this is with both defining features rule theory and prototype theory. I hope you are making notes about the concept you brought to this lesson to identify what attributes might help you teach this lesson better. Step 4 is to understand how this concept was originally learned. How have students experienced the concepts? Or how are they familiar with it? Is it through symbols or language or doing or seeing? Do they have the word for the concept you are trying to teach in their own language? What was the context in which it was learned? In school, in social setting, in casual observation? This is when we link informal to academic. Finally, we really have to look at the environmental influence of situated cognition, prior knowledge, activation of prior schemas. All of these issues come into play with subtle and not so subtle implications. This kind of pre-thinking is probably a skill you have long since mastered, but it is a good idea to take this process out and dust it off to see if it needs to be polished a bit with a new perspective. With increasing numbers of English language learners in our classrooms, we may have to look at concepts we take for granted in a new light. Additionally, even native English speakers may not have learned the concept you are trying to teach in a manner that supports academic achievement. Time out for a caveat, which is Latin for beware. What are the ramifications if students build a new academic concept with inaccuracies? What if they come to your class with serious misconceptions? In several historical studies about vocabulary acquisition in elementary-age children living in poverty in both rural and urban environments, it was found that their usable academic vocabulary was generally severely limited. Many times, some of the words they did have in their working vocabularies were not used with the standard English definitions, particularly in cases of heavy dialect. Sometimes children create naive theories to explain a concept. Of course, there are many ways children and adults too can have misconceptions. The point is, where achievement is key, the concepts have to be carefully built. Are you getting tired of hearing that yet? As you are probably well aware, diagnostic and formative assessment for the concept is crucial. Okay, now that we have a clear picture of what it is we need to teach, let's look at some ways to help us do it. Okay, let's review here for a moment. The basics for getting from a pile of blocks to a tower is a metaphor that we are going to use. Concepts are the building blocks of cognition. We use all three foundational theories of concept formation depending upon our learning objectives and our contexts. We've done the planning and the thinking, so we are going to leave our metaphor with Legos for just a moment and play with some plain old bugs. We are going to teach the concept arthropod. Is or is it not a bug? How would you like to wake up to this in your tent? What do you think? Is this a bug? Everyone has an opinion about bugs. Elementary students love to tell horror stories about bugs. For that matter, so do older students. The first step is to prime recall, to activate schemas or prior knowledge that will help students think of examples of bug. Start a discussion about experience with bugs. Get their prototypes to the top of their mental workbench, their working memory, by asking what they think of when you say bug. Mosquitoes, spiders, ants, anything just to get them started. For your English language learners, you might ask them what the word for bug is in their first language. Secondly, present multiple examples and non-examples. This is the good old exemplar theory at work. Good examples might be grasshoppers, crawdads or crayfish, or beetles. Non-examples would be a clam or a cat. Now we need to have some rules about what makes a bug a bug. We need to look at defining features and non-defining attributes. If you have taught for any length of time, you know what kind of responses students will generally make. From just 3 elements we've explored, you are well aware that some learners will have misconceptions. Now we will take it to the next level by introducing new vocabulary, which in this case is actually the new concept, arthropod. Whenever teaching a new concept, we always unpack the word. We always teach students the name of the concept, especially if it is something they have not encountered or have viewed differently in the past. Be careful to unpack the word. Does it come from Latin or Greek or other old roots? Where does this word come from? It might help students to remember the concept, to know its origin. Be precise in defining the concept for your learners. Not all creepy crawlies are arthropods. Let's unpack this word. An arthropod is an invertebrate, which is another concept. It's an invertebrate animal that has a skeleton on its outside, an exoskeleton made of chitin or hard shell, a segmented body, and jointed appendages or legs. Arthropods are members of the phylum Arthropoda. Arthropod comes from the Greek arthron, which means joint, and podos, which means foot. When we put arthron and podos together, we get jointed foot. So arthropods generally have feet with joints. Why is an earthworm not an arthropod? The 6th step of teaching new concepts is to add some visual aids, some examples. If your students can manipulate the examples, that's even better. Recall that wiring information into neural networks using all 3 modalities, visual, auditory, and motor, increases the likelihood that the information will be retained in long-term memory. That is learning, folks. Hearing something is highly forgettable. Seeing it and hearing it is a little bit better. But adding a motor component seems to create a different kind of learning synergy. Use all 3. Finally, teachers know that students often lack prior knowledge of a concept for many possible reasons. Perhaps the concept is not present in their cultural background, or students may not have been exposed to it earlier, or perhaps the concept may be too complex. One very useful tool here is analogical reasoning. An arthropod is like, or an arthropod has a skeleton like a person does, but our skeletons are on the inside. An arthropod skeleton is on the outside. It is a hard shell. When we create new neural networks, the strongest links are connected to something we already know. Making analogies between the new concept and a concept already learned helps connect to other neural links and strengthens recall from long-term memory. Wow, let's take a breath. We told you we were going to get theoretical, but what you have just viewed is not merely theory, but has years of empirical evidence behind it. Teach the foundation. Make the connections through all modalities. Add smell and taste if you can. The stronger the wiring, the better the recall. Learning facts in isolation, those that are not connected to anything, is surface learning that is quickly forgotten. The new mantra is, what wires together fires together, and out of sync, you lose your link. So let's regroup for just a moment. We have several steps here that might help us do even a better job in teaching concepts. We want to use a rule example strategy. Help students learn what a concept is and what it is not. We want to provide clear, concrete examples, and we want to relate new concepts to already known concepts. Create concept maps, generate hypotheses about concepts, prototype matching, check for understanding and generalization. Well, there you have it. One method for teaching concepts. The model we've explored is not the only model of concept formation, but it is an effective one. Perhaps you have another model you are partial to. Consider the similarities. I would wager the steps are much alike. I have to leave you with one last word. Well, two. Concept maps. We have avoided making concept maps in this lesson, not because they are not effective. They are. We have purposefully not drawn concept maps here because the best ones are drawn as you are presenting the new concept. Teachers like stand-up comics work the crowd and respond to the needs and connections of the moment. Draw these maps. Use an interactive whiteboard to let your students engage in collaboration to create them. Applications such as WeMap for tablet computers allow a class to collaborate by creating a whole group or whole class concept map, and then allows them to publish it in several different formats. The point is, when they're creating a map collaborative, we're wiring more neural networks. Take a moment and see what is here. What we have here is a concept map of a concept map. You might find this helpful. You might find that the steps will help you organize your own thinking a bit better. You will find a better version in the transcript of this lesson. Keep the goal in mind. Start with a foundational concept and build the basic academic idea. Then who knows where the foundation may lead? This castle has over 10,000 Lego pieces, but it started with just one brick, the foundation concept. Or maybe this, what a difference a good foundation makes. Thanks for spending your time with us viewing this lesson. Please help us to make professional development on your plan offerings better and more reflective of your needs. Tell us what you want and need. Please take a few moments and take the short survey that follows. Thank you.